APIs. So let me copy this test case and I'll use it as a baseline to create another one. And I'm going to say not should succeed, but should return access tokens. So now what I want to do here is after we get back the response message, we want to ensure that we get back a success status code. And then I'm going to say await response content read from JSON async, which is a helpful extension method that allows you to deserialize the response content into an object. So let me define an access token DTO. And what I want to validate here is that this value is not null. I'm not particularly concerned with the contents of the access token. I just want to make sure that it exists. Now we have to make sure that we use a different email. Otherwise, we're going to run into a concurrency problem if we reuse the same email value. So I'm going to run both of these tests. And let me open up Docker Desktop while my tests are running behind the scenes, because I want you to see these two containers here. The first container is what's actually running our test containers. And this is what's going to start the Postgres instance, which is now cleaned up after our tests have completed. So you can even see the containers running inside of your system while you're executing your integration tests. And then here you can see both of our tests are completing. One more improvement I'd like to make here is to introduce another type in the infrastructure folder, which I will call routes. So this is going to be a static class, and I'm going to use it to easily define my API routes so that I can reference them from my test classes. So let's define another nested class inside, and let's call it auth. And inside of it, I'm going to define a string value that's going to be my actual endpoint, and this will be register. So I'll call this the auth register endpoint. And what this allows me to do is get this nice syntax inside of my test cases where I can say routes auth register, and I no longer have to hard code the routes inside of my test cases. If I have routes with dynamic parameters, I can create static methods here where I can pass in the route parameters as arguments, and this will construct the proper URI that I can use inside of my test cases. Now I want to show you one more example. Let's define another route here. I'm going to call it login, and the path is going to be auth/login. This is what we already have in the auth controller in the login endpoint. So let me close down the controller, and I'll go into the integration test fixture where I want to create a private field. It's going to be an HTTP client instance that I will call the authorized client, and I'm going to drop in a helper that's going to allow me to obtain an authenticated client and use it inside of my test cases. If the authorized client is not null, then we're going to return this value. Otherwise, I'll create a default client, initialize a service scope so that I can validate that the user with the given email isn't already registered. If they are not, then I'm going to send a register request to the respective URI. Then we're going to proceed to authenticate the user by calling the login endpoint. This will give us back the access tokens, which I can use to set the authorization header on the HTTP client. And I'm going to make it reusable inside of my test cases. So what this allows me to do is to call an authenticated endpoint on behalf of a real user. So let's go ahead and create a new test class. I will call it the habits tests, and let's again implement our test fixture. So I'll specify the integration test fixture. We'll define the base constructor, and we can go ahead and create our first test case. I just want to test the happy path. Let's say create habit should succeed with valid parameters. Again, I'll specify the arrange, act, and assert format, and I'll create a valid DTO instance. You can grab it from the unit test that we already wrote in the previous lessons. Then I need to initialize my client. So I'll say await create authenticated client async. I can use the default parameters, and now that we have our DTO and our authenticated client, I can say await client post as JSON async, specify the URI to our habits routes. Let's say routes habits create. Then I'll pass in my DTO instance, and this should give me back an HTTP response message. Now let's first define the route that we are currently missing. So this will be public static class habits, and then let's define a constant inside. Let's call it create, and it's just the base URI, and we can omit the starting slash. So if I go back to my test case, I can write my assertion. So let's assert that we are getting back a 201 created HTTP status code. I'll provide the response status code for the assertion. And let's also assert that the location header on the response is not a null value. So I'll say response headers and then access the location header, and I want to confirm that this value is properly set. And I can also do an assert not null, and I can say await response content read from JSON async, and I can specify the habit DTO. So let's run our new test case and see if it's going to succeed. And you can see that our test case is passing with an authenticated HTTP client. So we're first registering a new user and then sending a request with the authorization header set on behalf of that user. This is going to create a new habit inside of our system, store it in the database, and return a 201 created response with the location header set to the correct value, and it's also going to return a habit DTO instance as the response. So I think you get the idea here. Now we can continue adding more test cases for the other use cases inside of our system. But what I want you to take away from this is that you can do proper integration testing using Docker containers to run your external services. The test setup also doesn't have to be complicated. All you should be doing is setting the proper configuration values, and then when it comes to how you want to share your test data, you can either use a class fixture, a collection fixture, or you could have chosen the option to initialize a new web application factory inside of all of your test cases. Now you might be wondering, how are all of our API requests actually succeeding and able to write anything to the database? Well, this is because the web application factory is actually going to run our application. And if you open up the program file, one of the calls that we have here is to apply the migrations and to seed any initial data. So this is absolutely perfect for our integration tests because we can ensure that our tests are always running with the latest database schema and that they have the required data to be able to satisfy our business rules. If you don't want to use this approach, an alternative is after you start the Postgres container, you have an option to run a SQL script. You can call the execute script async method and pass in the contents of your SQL script, and this is going to run on your container. Or a third option is to specify a file that you can attach to the container and is going to run the contents of this file when the container starts. I still think that the simplest approach for integration testing on ASP.NET Core application is to run the migrations at startup and seed any initial data. And with this, I'm going to wrap up the lesson about the integration testing our REST APIs, and we can move on to our next lesson, where we're going to talk about testing external services inside of our system. An example of this is the GitHub REST API that we are calling mainly from the GitHub controller, but we're also interacting with it from our background services, which are also running inside of our test cases. So this is also something we could test with integration or functional tests. So in the next lesson, I'll show you how to write integration tests for external services using a library called Wiremock.